Hello everyone, welcome to Almighty Tricks. So in this video we will be discussing about how we can insert a node in the linked list. And in my previous video I have already discussed why linked list is required and what should be the structure of the linked list and how we can traverse the linked list. So in this video we'll be discussing about how we can insert a node in the linked list, and in my next video I'll be discussing about how we can delete a node from the linked list. So I'll suggest just go through my previous video where I have discussed all these topics, then you can understand these two. Okay, so that link you can find in I button or maybe you can find in description. So let's get started with the how we can insert a node in the linked list. So as we know, the structure of the node is like we can have one data or value where we can store the actual value. Then we can have one next variable where we can store the address of the next node, and we can have multiple constructor, but currently I have only one constructor where I am passing one argument data, and that data I am storing it here, and I am storing next address as null. Okay, so this is the basic structure which I already discussed in my previous video. Now let's understand how we can insert a node in the linked list. Okay, so let's say this is the example, this is a linked list. Let's say this is the linked list. Okay, so we need to insert a node. Let's say one node, let's say this is a. Okay, this node we want to insert in the linked list. So there are two things. There are three things we need to understand. Like this node, we can this A node we can insert here, right? At the front we can insert, and we can insert at the end, right? And this node also we can insert in between these nodes, right? Here also we can insert in the middle or in between this front and hand. So we have three things. One is insert at front, then insert at end position, then third is insert in between of front and end node. Okay, I mean this here, this location. So let's understand one by one how we can do all these things. So let's understand about how we can insert a node at the front of the linked list. Okay, so let's say I have one node here. Okay, so this is my head, right? So this is my head. So I have one node which I need to insert. Where I need to insert in this place. Okay, so let's say I have one node, let's say X. So this is the node I want to insert at the front or head. Okay, so currently this is my head. So we know that this head has address of this node, right? So we have like this is the data and this is the address, let's say 204. So 204 address of this node. Okay, so we can come to this node by doing head equals to head dot next, right? So we have created this node. So we have this node, we want to add this node at the front. So how we can do that? So what I'll do, it has also next, right? So this is some data, let's say M, and address, let's say A. Okay, so currently it is null, so it has nothing, right? It has nothing. Currently it has null. So what I'll do, I'll connect, I'll this address should connect to this one. Okay, this address should connect to this one. So let's say this is this node address is 203. So this one will become 203. Okay, and this head will update to here, right? this head will update to here, because currently this is our head, but when we insert one new node, then our new node will be the new head, right? So let's understand how we can code this one. So what we can do, we can have we can let's say this is my function. So in the function, always it will give the head of the linked list. Let's say tree node, sorry, let's say node head. Okay, always it will give in the head in the question. Okay, now I need to insert, I let's say I the question is given, I need to insert 23 at the front. So what I'll do, I'll create one blank node, right? So how I can create node, new node equals to new node, right? Here I'll pass the 23. So in the constructor, when I'll pass, then it will create this kind of node, right? So it will create, this is the node which will have the data 23, and it will have the null address because it has nothing. Okay. Now, so this is my head, right? So what I'll do, so I need to connect this one with this, right? This node. So how can I connect this one? So I can connect like new node dot next, right? So new, this is the new node. This is my new node. So new node dot next means what? This is null is equals to, like, this is the head, right? So I'll assign the head, right? Done. Now now it is connected. Now it is connected. But I need to make this new node as head, right? So what I will do? So head equals to new node. Got it? So it will become head now. Got it? So so this is the very simple approach, and the time complexity it is taking order of one, because we are not going through any loop, just a single statement we are doing, just we are creating here, then we are just changing the pointers. Okay, so the time complexity to insert at the front is order of one. Okay, let's understand how we can insert one node at the end. Okay, so let's say this is my node, I want to insert at the end. So this is, let's say, A. So I have this like here I can have some data, and currently it is pointing to null. So there is no data. Okay, so it is pointing to null. Okay, so here if you observe this node, the current address is pointing to null. Okay, so what we can do, as it is pointing to null, so we have this new node, right? So this node has the next pointer, right? So that next pointer we can point to this new node, or removed, and it will connect it to this new node. Okay, and it is also pointing to, finally it is pointing to null. So this is the simple approach. So what we can do, so we have this head, right? This is the head. Okay, so this is the head. So in my previous video I already told, like, we should not move our head. Instead of that, we can create one temp node here. Okay, temp variable here. Okay, so this temp variable will move to end. So what we'll do, we'll move this temp here, then this temp will come here, then this temp will come here, and it will stop. Okay, so it will check whether this next node is null or not. Till that time it will move to the next node. Once once the next node is null, then it will stop there. And what it will do, the temp dot next will point to this a. Okay, let's write the code. So I can have one function here, let's say I am getting one node. here head. Yes, I want to insert 25 at the end. Okay, so here I can have new node A is equal to new node 25. Okay, so it will create like this. Okay, it will point to null. Okay, so now we have this head, right? So we need to create one temp variable which will have the head value. Okay, because we should not move our head, otherwise we will lose our all the information. Okay, so so we'll run the while loop here. In this while loop, what we need to write, I'll tell you later. So here basically what we can do, so temp dot next will be a, sorry, this is not a correct one. So here we'll move to next node, right? Temp equals to temp dot next. We'll dry run this code. Then finally we can have temp dot next is a. Okay, and here basically we can have temp dot next is not equals to null. Okay, so let's dry run this code. So basically, so let's say I have this one, two, three, then this is my linked list. Okay, and it is currently pointing to head. Okay, and I need to insert 25, 25. Okay, so from the code, first of all we are creating one temp variable here, right? Temp variable, and we are creating this node. So this node I have already created here, this one. So let's create the temp variable. Okay, so in the while loop we are checking if temp dot next is not equals to null. So temp dot next is what, 2, so it is not null, right? So it will come to this loop and it will update the temp. So now temp equals to temp dot next, temp equals to temp dot next means this will be the temp now. Okay, now again it will check temp dot next is not equals to null. Yes, it is not equals to null. So again it will move to this node temp. Okay, now again it will check temp dot next is not equals to null. No, it is not, it is equals to null. Okay, it is equals to null, so it will break the loop and it will come here. Okay, now this temp dot next, so temp dot next is currently pointing to null. Now temp dot next is pointing to a, so this is the a, right? So this is the a pointing to a. Okay, so that's all. Means we need to traverse till we get the null. Before that we need to assign to new node. Okay, so here time complexity will be order of n because we are going till the end of the linked list. Okay, we are traversing all the nodes and then we are going to the end, then we are inserting new nodes. So the time complexity is order of n. So this is going to be like, so it will given like one position, it will given in the question. Let's say position is given, let's say 2. So in the second position, we need to insert new node. Let's say new node, we need to insert, let's say, maybe we need to insert 23. Okay. So this node we need to insert. Okay. Let's say this is my linked list. Okay. Let's say 1, 2, 3. So we need to insert at the second position. So 1, this is the position, right? This is 1, 2, 3. So we need to insert at the second position. It means what? This will come to here. So we need to insert here. This 23 will insert here. Okay. So let's understand. So this is the node, right? So this is first node, so it is pointing to head. Okay, so this node's next, so this node's next will point to here, and this node next will point to here. Okay, and this will break. Okay, so this is the simple means this node next will point to new node, and new node next will point to this node. Okay, let's check the code how we can write this. So let's say we can have one function, and it is given the head. Okay, and we need to insert new node, so we'll write the new node later. Okay, so okay, let me write the new node here. Node a is equal to new node 23. So it means what? It means it will create a node 23 and it will point to null. Okay, now we need to back up this head, right? So we need to create one temp variable head. Okay, now what we'll do, so we need to insert, let's say we need to insert, so it is also given the position also. Position it will given. So let's say the position we need to insert 3, third position. Okay, so we can have one counter. We'll try run this one counter. Initially it is 1. Okay, so we'll check while counter is not equals to position. Okay, then what we'll do, we'll move our head, we'll move our temp, right? Temp is equal to temp dot next. Okay, once this counter is same as this position, then what we'll do, this temp basically will create another node to store the temps next. Let's say x. Okay, temp dot next. Okay, now this temp dot next will be the next new node, this a. Okay, this a. Now this a dot next will be what? A dot next will be x, right? Why I stored this one? Because we need to store the temp dot next, right? Temps next we need to store, so that's why I have created this one. So let's dry run this. So currently these positions are like 1, 2, 3, 4, and position to insert is given, position to insert is given 3. Okay, and this is our temp, and we need to insert 23. Okay, so currently it is null. Okay, so the so let's check the code. So what we did, we have created this a. Okay, we have created this a, correct? Now we have created this temp, so currently this is pointing to this head. Okay, now we have one counter. Let's create the counter. Counter is currently 1. Okay, now check while loop. So counter is not equals to position, so counter is currently 1. We need to insert in the position 3, so it is not satisfying, so temp will go to next. Okay, correct. Now counter, sorry, here we need to increment the counter as well. Okay, now counter will increase to 2. Okay, now again it's 2 is not equals to 3, correct? So temp will go to next pointer, next node. Okay, and counter will increment to 3. Okay, now if you see position is 3, counter is 3, so it will not go into this while loop. Okay, now it will come here, so this one, so node x equal to temp dot next. So it means what? in this x it will store this value. In this x it will store this value. Why it is storing, we'll understand later. Now temp dot next equals to x. So this temp dot next is currently it is pointing to 4. Okay, so now we need to point to here. Temp dot next equals to a. Okay, now age next currently it is pointing to null, right? But here it is saying age dot a dot next equals to x. So this is our x, right? So now this x will point to here. Okay, so it will not be there. So this temp will point to a. Then as next will point to this node. Okay, so if you observe here, we have inserted the node in between the linked list. So the time complexity of this approach will be order of and worst time complexity. Okay, and one more thing I want to mention, there are lots of edge cases we need to maintain. Let's say the position is given 10, but the total nodes are there like 8. So in this case it will not work, right? So those edge cases we need to handle. Let's say position is given -1. So this edge case also we need to handle. So I'm hoping that you can handle those edge cases. Otherwise, the main part of this code is I have already explained. You can go through once and you can try to implement. So if you have any doubt, maybe you can comment down below. And thank you for watching this video. And in next video, we'll be solving the deletion of the nodes from the linked list. Thank you for watching this video.